Friends, in this video, we would be learning how to select a pump for a solar photovoltaic pumping system for agricultural application. So we have the data in the form of requirement of water, how much water is required for irrigation. We have the data on what is the source of water available, what depth the water is, to what height we need to pump that water. Then we have the data on what is the efficiency of the pump, and from that we would be arriving at the pump capacity and how much input would go into the input in the form of electrical power would go into the motor of the pump. You know that pump is essentially a pump motor system. So these are very simple calculations, but it requires some understanding of the theory of the pumping system. So first I would be defining what is known as the hydraulic power of the pump. Then I would be telling you what the efficiency term means, and then we would do a small numerical case study kind of thing, which would help you appreciate how to select the pump and how to select the motor for a solar PV pumping system. Okay. So the basic understanding is about the capacity of the pump in terms of hydraulic power. We know that the desirable effect for a pump is the calculation of the water it can pump and to the height through which the water can be pumped. Okay, so this formula, that is P is equal to rho into G into H into Q, is the most important formula for calculating the hydraulic power of the pump. Now what does this term mean? This terms, rho is the density of the water, and approximately you can always remember this figure, that density of the water is about 1000 kgs per cubic meter. Okay, so this is the density of water. Now, G is, you are learning physics, that is G is the acceleration due to gravity, and its value is about 10 meters per second square, or to be precise, the value of G is 9.81 meter per second square. Remember, it's an acceleration, so it has got the units of acceleration, that is meters per second square. H is the head or the resistance through which the water has to be lifted. Okay, so this H is the total dynamic head, which we had defined in our lecture on essentials on pumping system, and that H has to be known or calculated. And Q is the flow rate, the desired flow rate for the pump, and that flow rate would be dependent on two things, that is the source of the water which is available, your pumping pattern, for how many hours you need to pump, and the total water required for your crops. Okay, that is called as the hydraulic power. The second important thing is the electrical input which goes into the motor. Okay, because pump would be driven by electricity, right, and the pump would be driven by a prime mover, which is a motor. Okay, so how much electricity would go into that? That is PE, and the ratio of P upon PE would be the overall efficiency of the pump and the motor. Okay, so that efficiency would range from 30% to 50%. I'm saying the combined efficiency of the pump as well as the motor. So it would include the mechanical losses in the pump. It will account for the mechanical losses in the pump as well as the losses in the electrical motor. So one can use the data which the manufacturer gives to look for these values of efficiency to calculate the pump capacity. Okay. With this basic understanding, let me tell you that these two terms, that is head and flow rate, they are the two crucial terms which we have discussed in quite a detail in our lecture on essentials of pumping system. So Q I will be denoting as a flow rate, and it is the cubic meters of water which is to be delivered per unit time. Okay. It could be in gallons per minute, it could be in liters per minute, whatever units you are choosing, but make sure that you are always choosing the consistent units for your calculations. In some countries, they follow the SI system. In that case, you would be using cubic meters per second as a unit of flow rate. Okay, uh, we can always do a Google search on conversion of one unit to other. For example, you might just type gallons per minute and how to convert gallons per minute into cubic meters per minute or cubic meters per second. You can readily get the conversion formula. So I'm not going into that in detail. Okay, so conceptually speaking, flow rate is the rate at which the water is to be given to the crops by the pump. Then this we had discussed in detail, but I'll just revise it. We must understand that the pump works under certain head, which is called as a dynamic head, which includes the vertical lift. Okay, vertical lift is as seen over here. It is the uh, height. Okay, height from the at what height the tank inlet is from the ground. Okay, so that is the vertical lift, or it is also called as a static lift. And then there is a suction static height, that is at what height the water is from the ground. Okay, so that is a water level. And then you must know the depth of the well, and you must know the frictional losses. So we would be assuming certain numbers, and that would be more clear. Just again have a look at this diagram and convince yourself. You can pause this video and convince yourselves that what is the static water level. Static water level is the difference between, it is this is static water level. You see that this is the static water level. Okay, and then there is a drawdown. Okay, then there is a drawdown. So this drawdown is the difference between the pump level and the static water level. Okay, the static water level is the ground level and the water level height. That is the static water level. And then you would see that this is the height through which you are lifting the water. That is the vertical lift. Okay, vertical lift. And the well would have a much greater depth. But why we should consider the well depth or the bore well depth? Because the piping would be for the entire depth of the well, and that piping uh, has got certain frictional losses. Okay, so we need to consider the entire piping length, and for that we need to consider the well depth. Okay, so with this understanding, uh, we would be calculating we'll take a small numerical, and then that would help us explain how we actually select a pump. So let us take down this numerical. You can open your notebooks and write down this numerical, uh, wherein you are given that this pump has to supply 7,000 liters of water. Okay, 7,000 liters of water. Okay, so you are not actually given the flow rate, but you are given the total water which is to be supplied. And let us say that water is to be supplied over a period of 5 hours. Why I am taking 5 hours, that would be clear to you when we discuss the solar availability. So why I am taking 5 hours for the time being, just remember that I am assuming that the solar hours per day are 5. Okay, solar hours per day are 5. So this pump, because it does not have a battery, so this pump would give you water only for the 5 hours when the sunshine is available, right? So this 7,000 liters is the total requirement which has to be supplied in the period of 5 hours. Okay, then it is given that the static, the elevation, that is the height, vertical lift. Okay, vertical lift or elevation. Now what did we say is the vertical lift? We said that it is the height of the tank. Okay, or more correctly, it is the height of the uh, inlet to the tank, right, from the ground level. Inlet to the tank from the ground level. And let us say that it is given to be 10 meters. Okay, 10 meters. And the standing water level, that is the static water level, the standing or the static water level Static water level or standing water level is what? It is basically the depth of the water as measured from the ground surface is 30 meters, and the drawdown is, let us say, 2 meters. Drawdown is, let us say, 2 meters. Okay. So now if you do an addition, neat addition of this, what you will get is the vertical lift. Okay, so the vertical lift would be how much? The total vertical lift, that is from the including the elevation and the standing water level and the drawdown. Okay, so this is 10 plus 30 plus 2, which is 42 meters, and the total dynamic head, which would include the frictional losses, total dynamic head, which is TDH, which includes the total frictional losses, would be 42 meters plus the frictional losses. Okay, frictional losses. Now let us assume that there is a frictional loss of 0.05 meters per meter. Okay, of the lift, per meter of the lift. If this is a frictional loss, if you assume that, then this would come as 42 into 0.05. Okay, and if you do this calculation, this comes out to be 2.1 meters. So the total dynamic head then works out to be around 44.1 meters. So this is your H. And we said that P is equal to rho G Q H. Okay. So rho is 1000. Rho you can take it as 1000 kg per meter cube. G is taken as 9.8. It is acceleration due to gravity, meters per second square. And then let us say that this is 7000 liters, that is 7 meter cube. Per hour is 5H, 5 hours, okay, per hour, 7 meter cube, 5 hours, okay, into head is 42 meters. Head is 44.1 meters, 44.1 meters, right? So this would give you around, do this calculation. Okay, this comes to my calculation shows that this is around 168 watts. 168 watts. Okay, convince yourselves that this is the case. Let me just calculate and check. Yeah, you can do the calculation. You can also do the calculation and check that this is the, yeah, so it is around 168 watts, right? 168 watts. So this is the hydraulic power. This is the hydraulic power which is expected to be delivered by the pump. Okay. Now, if you consider the pump and motor losses, and that is captured by the efficiency of the pump motor, and let me take it as around 30%. 30% is that. Then that would give me the electrical power input, which would be 168 upon 0.3. Okay, so this 168 watt is the hydraulic power of the pump, and 168 upon 0.3, which is about 560 watts, is the input to the pump. Okay, or more precisely, it is the input to the motor. So this way, by looking at the application, you can calculate the total dynamic head, and then knowing the density of the water knowing the acceleration due to gravity and your water requirement, water which can be delivered by the pump, you can calculate the hydraulic power. And by considering the pump motor efficiency from the manufacturer's catalog, one can arrive at the input or the motor capacity of the pump. Okay, so this way I have calculated about 560 watts, or in terms of horsepower, if this 560 watts is 560 upon 746 watt per HP, means it is about 0.75 HP pump I would be requiring for my application. So this way we select the pump. I hope that you have appreciated my calculations, and that that helps us actually in the field practically learn how to calculate the pump, select the pump in the real life applications. Okay, thank you.